Thomas Midgley Jr. was a chemist who made significant contributions to science in the early 20th century. Born in 1889, he was a brilliant mind who sought to solve some of the pressing issues of his time. His work led to innovations that were initially celebrated and widely adopted. He is known for inventing things that seemed helpful at the time, such as leaded gasoline and chlorofluorocarbons, or CFCs. These inventions were hailed as breakthroughs and brought him significant acclaim and recognition in the scientific community. However, his inventions had terrible consequences for the planet and human health. The widespread use of leaded gasoline resulted in severe air pollution and lead poisoning, affecting countless lives and ecosystems. Let's learn about the impact of his discoveries. Midgley's work with CFCs, initially used in refrigeration and aerosol sprays, led to the depletion of the ozone layer, exposing the Earth to harmful ultraviolet radiation. Midgley's inventions led to widespread environmental damage and health problems. The environmental and health crises that followed his innovations serve as a stark reminder of the unforeseen consequences of scientific advancements. Lead from gasoline polluted the air and poisoned people, causing neurological damage and other serious health issues. The impact was felt globally, with entire generations affected by the toxic legacy of leaded fuel. CFCs damaged the ozone layer, which protects us from harmful radiation from the sun. The resulting ozone depletion has had long-lasting effects on the environment and human health, including increased rates of skin cancer and cataracts. The story of Thomas Midgley Jr. is a cautionary tale. It highlights the importance of considering the long-term impacts of scientific and technological advancements. It reminds us that scientific progress should not come at the cost of human health and the environment. We must strive for innovations that are sustainable and beneficial for all. We must consider the potential consequences of our discoveries and inventions. By learning from the past, we can work towards a future where science and technology coexist harmoniously with nature. One of Midgley's most significant inventions was adding lead to gasoline. This innovation was seen as a breakthrough in the automotive industry. This aimed to reduce engine knocking, a common problem in cars back then. Engine knocking not only caused inefficiency, but also led to significant wear and tear on engines. Leaded gasoline seemed like a good idea initially, as it improved engine performance. Cars ran more smoothly and the lifespan of engines increased, making it a popular choice among consumers and manufacturers alike. However, we now know that lead is one of the most potent neurotoxins on Earth. Even small amounts of lead cause significant harm to the human body, particularly the nervous system. Lead exposure caused severe health problems, especially in children. Young children were particularly vulnerable because their bodies absorbed the lead more easily and their developing brains were left susceptible to its toxic effects. Lead exposure resulted in widespread developmental delays, learning difficulties, and child mortality. The impact on cognitive development was profound and irreversible, severely damaging following generations' learning and cognitive abilities, which can be observed by plummeting IQ levels and retarded brain development in the years following the widespread adoption of leaded gasoline. The use of leaded gasoline became widespread, and as a result, lead contaminated the environment. This contamination was not limited to urban areas, but spread to rural regions as well. Lead particles settled in the soil, water, and air. Over time, these particles accumulated, leading to widespread environmental pollution that resulted in irreversible damage to ecosystems and human health for generations to come. People inhaled lead, and it entered the food chain. Contaminated soil and water meant that crops and livestock were also affected, leading to a vicious cycle of exposure through the food we eat. This widespread lead contamination had a devastating impact on public health, particularly children's neurological development. The legacy of leaded gasoline is a stark reminder of the unintended consequences of industrial advancements. Midgley also played a key role in developing chlorofluorocarbons, or CFCs. These chemicals were revolutionary at the time. CFCs were used in refrigerators, air conditioners, and aerosol sprays. They were incredibly popular because they were stable, non-toxic, and non-flammable. They seemed like miracle chemicals because they were non-toxic and non-flammable. This made them ideal for a variety of household and industrial applications. However, scientists discovered that CFCs were destroying the ozone layer. This was a significant environmental concern that took years to fully understand. The ozone layer is a protective shield in the Earth's stratosphere that absorbs most of the sun's harmful ultraviolet radiation. Without it, life on Earth would be exposed to dangerous levels of UV rays. CFCs released into the atmosphere rise to the stratosphere, where they break down ozone molecules. This process creates holes in the ozone layer, particularly over the polar regions. The depletion of the ozone layer allows more UV radiation to reach the Earth's surface, and resulted in widespread skin cancer, cataracts, and other health problems. This has led to global efforts to reduce and eventually eliminate the use of CFCs. If you found this information fascinating, don't forget to comment, share, like, and subscribe to the Science and History Archives channel. Stay tuned for more intriguing scientific and historical insights.